Okay, hi folks, this is segment 3 and that's where we stopped last time. So the structure that we have is shown to you on the top, and then we looped through the elements and one by one wrote down the equation of motion and assembled it into the mass matrix, the stiffness matrix, and the load vector. We now have to decide what do we do with these things that we've got there. For example, let us look at this entry that you see here. This entry. It's referring to element number 1, which is the spring on the very left side, and it's referring to a lumped mass at the left end of element number 1. In other words, at this location. However, there is no mass there, so this is going to be 0. By the same token, you look at the last entry here. This is referring to element number 4. Notice the superscript, it says 4, so it's coming from element number 4, which is right here. And it's referring to the right end of that element, which is node 5, and that is the wall. Therefore, this is 0. There is no lumped mass there. If you don't like that explanation, don't let it bother you too much, because after all, x1 that you see here, x1, this is x1 double dot. x1 itself is the displacement of node number 1, which is the wall. So this is 0. So even though you may not like the argument that I give you, you might say, okay, there is this m1l, but it's multiplied by 0, so it's really irrelevant. Okay? And by the same token, this is 0. This is the acceleration at node 5, which is the wall on the very right hand side, and that is 0. And if you don't like my explanation of m at the right point of element 4, saying that it's 0, well, it's multiplied by 0 anyways. By the way, you notice that this is 0 and this is 0. Okay. Now let's go to this entry. It's referring to the right end of element 1 and the left end of element 2. So what exactly is that location? The right end of element 1 and the left end of element 2. That is precisely this location. And it's the sum of the masses coming from the two different sides. In other words, when you look at the look at the generic elements of 1 and element of 2, it's referring to the sum of the masses coming from the two different sides at that location. And therefore, this is m2, the number that's given to us. You look at this guy, this is the right end of element 2. Here's element 2, you can see that. This is element 2. The right end of it is this location, node 3. And the mass from the left end of element 3, which is the spring to the right of that. In other words, it's referring to the sum of the masses at node number 3. And this is given to you as M3. By the same explanation, this is M4. M4. All right. What about these guys? Well, nothing. Their stiffnesses, whatever they are, if they're the same, for example, this is going to be K1 plus K2. If they happen to be the same, you get 2 of the stiffness of one of them. The point is that these are the stiffnesses of the springs given, You know the values, you can plug it in. Okay. Now, look at this fellow. This is referring to element number 1 because of the superscript 1 and the left end of it. The left end of element number 1 is the wall, the left wall. And it's the force applied there or existing there. This is the unknown reaction force. We have to find this actually. And by the same token, this is referring to element number 4. That 4, superscript 4, means that it's talking about, it's referring to element 4, which is the spring on the very right hand side. And it's referring to the right end of it. So that's another wall. So this is another reaction force that we have to find. How about these guys? All right, same explanation. You have F right, superscript 1. So it's looking at element number 1, and it is the right end of element number 1, which is this location, right? This location, plus the left end of element number 2, which is exactly the same location. And this is sum of all the forces applied at that location. This is given to us. The big F that you see up there, right there. From the very beginning, we assume that there's a force there, and it's F. So that's F. If you look at this one, it's referring to element number 2, right end, and element number 3, left end. That's this location. Node 3, sum of all the forces applied to node number 3, and this is 0, because there is no force applied there. There are forces, but those are internal forces coming from the springs, but in the equation of motion, Newton's law is the sum of all the external forces is equal to mass times acceleration. Anyway, same explanation. This is 0. We got a problem here. I think this thing froze on me. Oh no, maybe not. Okay, let's stop this.